Geometrics is proud to present the G-862 Remote Base Station, our newest, fastest, and most complete base station system. This assembly video will demonstrate how easily it can be put together in the field. First, locate all 5 staff sections. One staff should have 2 rubber jackets around it. 3 staffs will make up the tripod and should have rubber crutch tips on the ends. Another staff will be attached to the sensor electronics bottle. Also locate the pyramid staff section and dog catcher Datalogger console. To start building the tripod, slip the first staff section into one of the bottom 3 slits on the pyramid and tighten the knob. Attach the second staff section, which holds the sensor electronics, in the same manner. To complete the standing tripod, we must attach the Datalogger console to its staff section, which has rubber jackets around it. First, completely loosen the latch on the back of the console by unscrewing the 2 bolt locks. Flip the console around to ensure that the lid will open upward once attached to the tripod. Align the rubber jackets with the 2 latches and tighten the latches by screwing the bolts back down. Attach this final leg of the tripod and tighten the knob as you did with the other staff sections. Next, we will attach the Cesium sensor. Locate the white and gray sensor clamp. The sensor clamp is used to fix the sensor to the tripod and to secure the sensor in the proper orientation depending on the magnetic field inclination of the survey area. Slide the sensor into the hole in the clamp and tighten the knob closest to the sensor. The staff will go in the smaller hole. Make sure the knob is as loose as possible to fit the staff section through. With a little force, push the staff section through the hole until the sensor is about 3/4 of the way up the staff. Make sure to tighten the knob on the sensor clamp. Slide this 4th staff piece into the top slit of the pyramid and tighten the knob. Now locate the GPS assembly. Remove the tie wrap and uncoil the cable. Locate the final staff piece and slide the knob end of the staff piece into the bottom slit of the GPS staff assembly and tighten the knob. Place this staff piece on top of the uppermost staff piece and secure by tightening the knob. It is recommended to wrap the excess cable around the staff pieces to reduce any movement of the system components. The cables can be secured with tie wraps, which come in your ship kit. The next step is to connect the GPS, sensor, and power cables to the Datalogger box. Locate the short sensor power data cable. One end of this cable has 19 pins and connects to the sensor electronics bottle. You can use the grooves on the outer locking ring to help make the connection. The smaller end of this cable has 5 pins and connects to the back of the Datalogger box. Once again, you can use the grooves on the outer locking ring to help make the connection. The GPS cable has a 19-pin connector that connects to the central connector on the back of the Datalogger box. Locate the red and black battery jumper cable, which will supply power to the system from a 12-volt car battery. This cable has a 3-pin connector and connects to the rightmost connector on the back of the Datalogger box. The clips on the opposite end of the cable connect to a 12-volt car battery, which can be used for powering the system. Turn the system on by flipping the power switch to the up position. Now that the system has been powered up, I'd like to point out the lighted components of the Datalogger display. On the front panel, we have 4 different areas with their associated lights. In the power area, there's a green light, which indicates that power is coming into the unit. In the processor status area, there are 4 lights: blue, amber, green, and white. The blue light is reserved for future use. The amber light tells us that RS-232 communications and a 1 pps pulse are coming in from the GPS. The flashing green light shows that data is coming in at 10 Hz. We can confirm a 10 Hz sample rate because the light is flashing 10 times a second. The white light shows that there is a 1 pps pulse and that the magnetometer cycling rate is phase locked to the 1 pps pulse. In the USB memory stick area, there are 2 lights, red and green. The red flashing light indicates that data is being recorded to the memory stick. The green light tells us that a memory stick has been inserted into the USB memory port and that the unit recognizes the USB device. In the Bluetooth area, we have 3 lights, red, amber, and blue. The red light indicates that power is coming into the unit. The amber light lets us know that data is being received from the Bluetooth device. And the blue light tells us that we have achieved connectivity with a Bluetooth device. Because the G-862 RBS is lightweight, portable, and easily assembled in the field, makes it the perfect instrument for correcting data from land, marine, or airborne surveys.
Pricing and contact information can be found on our website at www.geometrics.com or simply call us at 408-954-0522.